Good morning. You can hear me? This is so weird. And everyone's like, yeah, it's fine, we know, but it's cool. Okay, so good morning. How's everyone doing? Silent thumbs up? Okay. I can also hear my voice, which is a little bit weird, but it's okay. All right, so thank you for joining this this presentation. We're going to start off with a very special thing. So who has heard this paradigm before called fit body and fit mind? Quite a few of you, right? So what that means, for those of you who don't know, is that in order for you to be able to listen and focus and concentrate on what I'm going to say, you need to do some exercise because that will get these brain juices to flow. So in light of this, I would like to very kindly ask you to stand up. We're going to do a little exercise together, okay? And what's funny, and this is going to be really funny because all these other stages and people will look at us thinking, what are these guys doing? So the exercise is going to be a very simple exercise. I'm going to show it to you by showing my back, so apologies for that. So what you need to do is raise up your arms so that your elbow is in line with your eyes. Yep. And you see all the reactions from other people. They have no idea what's going on. This is brilliant. Okay, so open up your palms. And now put your palms together very loudly, repeatedly. Yeah, keep on doing it, keep on doing it, keep on doing it. Yes, thank you. Awesome. I love. You should see the reactions. People are like, okay. So for those of you who still don't get it, this is a standing ovation. So what I do, I take these pictures, send it to my boss, and he has zero idea what I say to developers so that they stand up and they clap frenetically. So thank you for that. Anyhow, on a more serious note, so I'm here to talk to you about video optimization of the web. So we're going to break this down into 5 acts, since this is a ballet, so I had to go with the title of the talk. And the first part is going to be about video optimization of the web. So video on the web, I don't know, is there anyone here who already uses video on the web? Meaning you have a project or a website where you display videos. All right, cool. So let's see what hopefully I can share a couple of insights with you that you will be able to put down into practice. So video content is important, right? The reason why it's important is because a video could convey a lot of messages. They say a picture is worth 1,000 words. They also say that a video is then worth probably 10,000 words, right? Because in a 30-second video or a 15-second video, you can convey a lot of messages. There's lots of stats in here. We can, this is from a project called the Web Almanac or the HTTP Archive. You can look this up. It's a Google-based project where basically you can see how video consumption has grown over the past couple of years. But also, a video is good because it captivates, it resonates with people, it does provide educational material, and more importantly, it does convey a particular message much, much faster, okay? So it's really great. However, if you have ever worked with video or you plan on working with video, you will realize that a video, videos are very heavy resources. You won't have a 1 megabyte video, you should have 10, 50, 100 megabyte videos. So they consume a lot of bandwidth, they could have compatibility issues, you have different encodings, etc., etc. It has particular impacts on your performance. It can pose technical challenges in terms of the implementation. So there are a lot of challenges with video as well. So we're going to go through some of these challenges, and hopefully by the end you'll have some solutions that will help you to solve these. Okay, so that's the idea of this talk. So how can we make sure that we display these engaging videos or any video on the web in the most performant way? So the second act, let's talk about encoding. What is an encoding when it comes to videos? So encoding, very simply put, is a way for you to reduce the size of your video asset by applying some optimization algorithm to it. Okay, so let's first do a conceptual math. Okay, so let's say you have a video which is 1 minute, and this video is 30 frames per second, which means we're talking about 1,800 frames, right? So that's 30 frames per second times 60 for 1 minute, okay? Now we are also going to assume that this video is 1920 by 1080 pixels, so that's a classic 1080p video. So those pixels mean that you have 2 million pixels, 2 million pixels total per frame, okay? Now, if you assume that you're using RGB, red, green, and blue, so that's 3 channels per pixel, you're going to have 5.93 megabytes, or close to 6 megabytes, for your video, times 1,800, right? Because that's the number of frames. So that results in 10 gigabytes. I see your faces, you're thinking, well, hang on, 1 minute for 10 gigabytes? Correct, right? The last time you watched a 1 minute video on your phone or on your device, that didn't use up 10 gigabytes, so something is probably off, right? So the reason for that is because of encoding, right? The raw video size could be 10 gigabytes, but because of the various encoding mechanisms that would be applied to the video, you're not actually viewing a video that is, 10 gigabytes, not 1 gigabyte. Okay, so basically, during an encoding procedure, or what an encoding really is just you take a compressed version of the video. Now, how do you compress the video? Is because you would use a specific standard. So there are multiple standards, which I'm going to talk to you about. And as those standards or those optimization algorithms would then change something in the video, which we'll talk about in a minute, and that's why a 1 minute video is not going to be 10 gigabytes, but instead it's going to be, maybe 100 megabytes or so. So what are these standards? So these are some of the most popular standards out there. So H.264, H.265, AV1, and VP9. So these are all sort of encoding mechanisms. Now, I just have information about 2 of them. H.64 is the encoding mechanism that is most widely used on videos today, okay? But because it's relatively old and it has been around for quite a while, it's not as efficient as a VP9 or as an EV1 encoding. But the quote-unquote problem with the VP9 and AV1 encodings is that even though they are more efficient in how they encode your videos, it may not have the same widespread support across the different browsers. But regardless of which encoding you use, everything just all boils down to this thing called the bitrate, okay? A bitrate of the video. So what is the bitrate of the video, I hear you ask? So essentially, the way you can think about this is that if a video has a higher bitrate, it means that the quality of the video is going to be much higher or much better. But also, because it's a higher bitrate and a higher quality, that also means that the video size is going to be much, much larger. And because the video size is much larger in terms of the megabytes or gigabytes even, that is going to affect how fast that video is going to load in the browser. Therefore, it's going to affect your bandwidth usage as well. If you're interested, again, the math for bitrate is the data size in bits divided by the time of the length of the video expressed in seconds. Okay, but the bitrate basically says how much data is being transmitted over a certain period of time. Okay, again, higher bitrate means higher quality, but also higher size. So here's the thing. Hopefully, there's no DevWorld organizer here, because what I've done. So have you all been to the DevWorld website? What they do, they load a video on the front page, correct? Okay, so let's see what they do. So hopefully they're not listening. So this is the video. By the way, in Chrome DevTools, and this is the first tip that I would like to share with you, you can actually have a standalone media tab, which would allow you to explore the videos on the given page. And it gives you very detailed information about what the videos do and how they are encoded and other pieces of information. But this media panel or media tab, you have to you have to add that manually. So it's in one of the sort of hidden menus. So their video is 59 seconds, it's close to 50 megabytes, and its bitrate is 6,697 kilobytes, and the encoding is H.264. Now, I took this video, I uploaded it to Cloudinary, but more on that later, and the same video became just 11 megabytes. Okay, the bitrate was also lowered, but the bitrate, the difference between 6,000 and 1,500 in this case, resulted in exactly the same quality of the video. So there was no visible quality reduction. But also notice that the codec or the encoding was changed from H.264 to VP9. Okay, so it's a more efficient encoding. So now, just by using a different encoding, lowering the bitrate, the exact same video at exactly the same quality, exactly the same length, became just 11.30 megabytes from the previous, 4950, whatever. Okay? So, and obviously, what's going to load faster in your browser, 60 megabytes or 11? It's so funny to have this conversation like this. Anyway, so obviously the 11 megabytes. Okay, so Act 3, performance. So our goal is going to be very simple, right? We want to make sure that the video that we have is going to load as fast as possible to have a much greater user experience, right? The faster the video loads, the faster users will get engaged. They can enjoy your site or enjoy whatever we're trying to show. So it's going to result in a greater user experience. Now, in terms of web performance, we can't sort of avoid talking about the core web vitals, right? So who here knows about core web vitals? Largest contentful paint, cumulative layout shift, first input delay, and then in 2 weeks, interaction to next paint. Okay, so these are the 3 ones. So the native video element, which we have access to in HTML5 or in HTML in general, affects the largest contentful paint as well as the cumulative layout shift. So these 2 metrics are affected by it. Now for cumulative layout shift, I think that's the easiest to get through with. So for those of you who don't know, cumulative layout shift basically measures how much content on a particular page shifts, or how much it moves around, right? And the more movement you have of the elements, the more you're going to be penalized by this CLS metric, okay? So what that means is that also for a video element, you want to make sure that you reserve the space on the site where the video element is going to be loaded. Okay, and the solution is very simple. You just specify the width and the height of the video element, either like this or from CSS. It doesn't really matter. Just one slight note here as well. All the browsers, maybe browsers from 1 or 2 years ago, if you had a video element that was responsive and you didn't add the aspect ratio CSS property to it, it would actually forcibly change the aspect ratio of the video element to 2:1, even though you had it 4:3 or something else. Okay, so just FYI. So if you don't have the width and height added to a video element, and this is just from a random website, the CLS could be in the orange or it could be in the danger zone as well. But if you add the width and the height, of course, there's not going to be any content shift, and as such, your CLS is going to be 0. Okay, so that's simple. Just remember, just block the space out for the video that you want to add to your site. So now comes the difficult and really interesting bit, which is LCP. So LCP is the largest contentful paint, which basically a metric that measures how long the largest element on your page in the visible viewport took to load. Okay? Now, there was a change. So we are at Chrome 122-ish, I think. Anyway, so back in 116, they introduced a change on how the calculations are done for the largest contentful paint metric. And the calculation meant that they are now calculating LCP for situations when the largest element is a video. But there are a few nuances about that. So first of all, LCP considers the poster image or the first frame of the video that got loaded. And whichever is faster, they literally, if the poster attribute for the video loads first, that's your LCP score. If you don't have one, or it doesn't load, or the first frame of the video would load before, then that's what they use for the time to calculate LCP. Okay, so whichever is faster. Now, we are developers, right? So our first thought is, I'm sure I can get around this particular thing. And, we can trick the system. So the next 2 examples that I will show you come from real websites where developers thought, let's be creative and, get a very fast LCP score. So option number 1, not my favorite, but still, someone did. So these are from real sites. Obviously, I changed I don't have the full URL for the video. So let's add the poster attribute. And what you see here is the data URI to a 1 pixel wide GIF. Because you think, well, a 1 pixel wide GIF is going to load in a couple of milliseconds, so therefore my LCP will be skyrocketing. So this will not work. Why does this not work? Is because Chrome also introduced, I think in version 112 or something, they introduced a calculation limit for LCP. So they now ignore what we call low entropy images. Low entropy is expressed in bytes per pixel, so anything that's less than, any image that has a BPP less than 0.05 is ignored in an LCP calculation. That GIF is less than this, and therefore it's not being used in the calculation. But again, we're developers, so we're like, okay, haha, I have another solution. So again, this comes from another site. Well, okay, if a 1 by 1 pixel GIF doesn't work, why don't we use an SVG, which is an empty square, 20 by 20? No. Okay, it will not work. Why? So the only scenario where an SVG is taken into consideration for your LCP calculation is if the SVG contains an image element. Okay, in this case, it didn't. So the big question is, how do I optimize my video for LCP? Now, I have 8 minutes, so I need to speak a little bit faster, or you need to listen faster. Please, thank you. So LCP, again, I don't want to go down the route of explaining what LCP is, but basically LCP is a calculation of 4 things: time to first byte, resource load delay, resource load time, and element render delay. Optimizing any of these 4 sub-items for LCP will mean that your overall LCP score is also going to get better. So what we're going to focus on is how can we optimize the video and the poster so that an actual real poster image or a real video's first frame is going to load a lot faster. So the strategies that you can apply are apply a different encoding to your video, lower the bitrate of the video. Here's an interesting one for you. Remove the audio channel. You know how many times I've seen background videos on websites with an audio channel? You can't unmute the video, you don't even have the controls, there's not going to be sound. So removing the audio channel will save you a couple of kilobytes still, okay? So don't have an audio channel on the video if it's playing in the background. And add the poster attribute pointing to an optimized image. So a very popular technique, again, by developers is to create different versions of the video. So create an MP4 version, create a WebM version, which uses a different encoding, and so offer that up. Now, by the way, MP4 and WebM are so-called video containers. Okay, they are not video encodings. And a video container means that it contains information about the video, the audio, and the metadata. Okay, just FYI. And so, by the way, do you know why a codec is called a codec, or video codec? It's encoding and decoding. Okay. Anyway, so these encodings are then used to compress and decompress the data found in these MP4 and WebM containers. But anyway, so let's assume you created an MP4 file, you created a WebM file, obviously because it uses, say, a VP9 encoding is going to be much lower in size. And so now inside your HTML, one possible solution for you to offer up these files would be like this. You have the video element, multiple sources, you put the WebM first, you put the MP4 second, and then the browser will play whichever version or whichever format it understands. If it understands WebM, it's going to play the WebM. If it doesn't, it's going to fall back to MP4 because the MP4 format or the MP4 extension is pretty much understood by every single browser out there today. But please do remember that the order of how you specify the source items matters. Okay, and here's an example again coming from a real website where they put the MP4 first, followed by a WebM, followed by an OGV. And then under that, what you see is data gathered from, I think that's 2021 or 2022, what are the most popular combinations of source elements on the web. And it's MP4 first, WebM second in 26% of the cases. Incorrect. If you put the MP4 first, which is technically not your optimized video, and because every single browser understands it, no browser will get to the WebM or other optimized videos ever. Okay, so remember, the order matters. Put the most optimal video format first, followed by the last one, which should be the MP4, which technically is your fallback video. Okay. The other question is, because I said, LCP takes either the first frame of the video into consideration or the poster attribute. So how do you know if you need to now optimize the poster attribute or you need to optimize the video? What is LCP using? How can you tell? And unfortunately, the Chrome DevTools UI doesn't tell you this. However, and you may want to take a picture of this real quick, by running this code, by using the Performance Observer API, you can print out your LCP candidate, and in that object, there's going to be a URL, which I'll show you in a second, and if the URL points to the video, like the MP4, then the first frame was used for the calculation. If it's pointing to a JPEG, to your poster attribute, then that's the item that was used. So I ran this, And you can see, I didn't move the arrow, I'm sorry. So you see the last property there, it says URL, and this one points to a .jpeg file. The poster attribute was used for the LCP. In the next example, it points to an MP4, so the first frame of the video was used for the LCP calculation. So this is how you tell. Okay. 3 more minutes for 30 more slides. Okay, ready. So next one, Act 4. I really want to talk about this, adaptive bitrate streaming. We're going to whiz through this real fast. So who here has a subscription to Netflix, Amazon Prime, HBO Go, Disney Plus? I know everyone has a subscription to something. So have you ever had this when you start playing a video in one of these services, the first couple of seconds are very pixelated, muffled sound, but then it gets, you get a higher quality. So what you're witnessing is adaptive bitrate streaming. I'm just going to bring this one up. So basically, adaptive bitrate streaming means that you have multiple versions of the video at different qualities, and then you have a video player which is then able to pick the appropriate quality based on your network conditions and your CPU utilization. So if you have a very slow network, it's going to pick a lower quality video and play that, but it constantly monitors your speed, and so when the video or your network frees up, or now you have access to more CPU power, then it's going to start streaming a higher quality version of the video. Okay? And so we're going to get through this. So your video may start off like this, and then it's going to become like this. Okay? So this, you've seen this before, I'm sure. So the way this works is that there is a so-called master playlist, an M38U file, which then contains all the metadata and all the other data for your video player to start streaming the appropriate quality. There are 2 standards. We're not going to get there because I'm going to run out of time. So HLS, HTTP live streaming, MPEG-, dynamic adaptive streaming over HTTP. But basically, what you need to remember is that if you have a video, you need to create a so-called variant of the video, and the variants would be the different bit rates, the different encodings, and the different resolutions of the same thing. And that's what you put into that master playlist file, and then the video player will be able to pick the right file to play. Okay, the finale. So that's a lot to unpack. I'm keep on talking a lot, blah, blah, blah. So can you do this all in once? Yes, you can. So that's the good news, right? So I do work for this company called Cloudinner. We have a booth at the very corner there, so please come and chat if you have more questions about this. But here's one interesting solution for you, where I'm loading a video, and I'm using F-Auto and Q-Auto on the video, which means we do automatic quality reduction on the video, plus we offer up the video in the most appropriate format. So this is going to change the bitrate, the encoding, and everything else, making sure that even though it's an MP4, it's still going to offer up maybe a VP9 encoded WebM, depending on the browser. Plus, notice I'm using exactly the same URL. I just replaced the poster attributes extension from MP4 to .jpeg, and now I get a heavily optimized poster attribute as well. The SO attribute actually takes the 127th frame from the same video and uses it as a still image that I use for the poster attribute. So with this, you get automatic format, automatic quality, and a frame-based poster selection, which is optimized. Here's some stats. So originally was 192 megabytes, and I got it down to 64 with a much lower bitrate. And on different browsers, because Safari doesn't want to use the VP9, they have their own little encoding, which is H265. But Cloudinner, basically figures that out and serves up the video format in the right way. Okay, maybe 1 more minute. We also have a video player. So what happens with this? You can specify the source type to be HLS. So we automatically support adaptive bitrate streaming. And then you specify a streaming profile. And if you specify that full HD streaming profile, Cloudinner will automatically create all these formats at varying bitrates. It will also generate the master playlist file that will look like this. And now you put this into our video player, and then the adaptive bitrate streaming is now done out of the box, and it's going to start playing the lower quality or the higher quality version of the video based on network conditions and CPU utilization. Okay, a couple of more things, and I promise you I'm done. So we have a couple of interesting features. These are just small videos. This is shoppable video, where you have a couple of items in your video, and you can actually get Cloudinner to find where those items are. go back to the appropriate frame, and then now you click it, and now you could go to an e-commerce store to buy the actual product. We also have AI-based summarization, where you have a 2-minute video, and you say, give me a 15-second overview, where Cloudinary will take a look at the most important frames and stitch them together as a summary for you. So it's good for previews and other things. Last but not least, AI-based cropping. So you can actually specify how or what object you want the crop to happen on. So notice GAutoBore is going to crop the video at all times following the object that you have specified in the condition. Okay? So, video is engaging, it's great, but getting it right and serving it right and making sure that you tick all these performance boxes is going to be quintessential. If you would like to learn more about Cloudinary and video in general, that's a QR code for you to scan and read about. I'll let you take a picture of that. 5, 4, 3, 2, 1. Next QR code, if you would like to sign up to Cloudinary and receive extra credits, then there's a different QR code. So with this, you can just fill out a form, and you can claim, I think, 3 extra monthly credits, which you can use in your project. So again, 5, 4, 3, 2, 1. And with that, I'm out. Thank you very much for listening. Hope you enjoy this, and enjoy the rest of the conference. Thank you.